Hey guys, I thought I'll make a video to talk about the life cycle of an HTTP request in Node.js and what's the best way than actually building a small application with HTTP vanilla Node.js HTTP server and then show you how that actually works. How about we jump into it? Let's go ahead and create a brand new project here. I'm going to call it requests node, and then I'm going to build a quick yes, we trust. Right, I'm gonna go build a quick Node.js library right here. Index.js, and let's go ahead and import the HTTP library because that's what we're gonna use. And then we're gonna go ahead and create a server here. Off of that, do we get IntelliSense? Thank you. Right, and just by creating that server, we get the server object, which we can add events to. And one of the beautiful events is called request, which means when a request, an HTTP request that is, obviously, because we're dealing with HTTP, arrives to me as Node.js, please call this function. That's exactly what it means. So I'm going to go ahead and just type 1 here. Right? So when a request arrives, I'm going to print 1. I'm not going to respond to the client here. So this is what I'm going to do here. And then obviously going to do just do a listen to port 8080. Yeah, let's listen on all interfaces. And then just do console.log listening. Listening. Alright, quickly initialize the project, npm init, .y, all that jazz. Let's go ahead and run. And this is Node.js. We're getting yelled at because we used ES6 and this is JS. So either I can do this as an MJS or just add a, what was it, type, I think. That's what they say, right? Just like I have to use type module because I used the ES6 things. Module. Yeah, that should do it. Because I used that new thing. Okay, we're listening, right? So now, while we're listening, what I'm going to do is I'm going to use curl. I'm going to use curl to make a request to my beautiful HTTP server. And I can either do it this way, right? And if I want it to be fancy, I can do it this way. And if I want it to be even fancier, I can do it this way. Boom, boom, boom. Okay? All of this is the same thing because I listen to all my interfaces. That includes all the local IP addresses effectively, including IPv6. This is the IPv6 local loopback. So if I do enter, what we're going to do here is we'll go back to the debug and we can see that 1 was printed and curl is waiting effectively. So it sends all the request, but it's just sitting here and waiting, right? Because we never actually responded. So it's going to kill that. And now what I'm going to do is I'm going to copy and paste that and add multiple events to the request event handler, which means usually when you see this, you know, it's not very clear what the application will do, right? Will the last one wins? Will it be called one after the other? Will the first one wins? You don't know, right? So how about we actually test it and see what will exactly happen? Some of you might already know the answer to that, but it's better to actually see it. All right, so I'm going to go ahead and do another curl v. You can see the call was sent. The TCP connection was established, obviously, to the destination. We sent, this is the first line, the second line, this is the header, right? There's another header, and then a new line, and there is nobody because it's a GET request. And then when you actually look at the debug, we printed 1 and 2 and 3, which means that whole unit was sent as an object and was passed to that function as this parameter request. And obviously we printed one. And once this function exited, immediately Node.js called the second one because it's one request. And then passed that same request, right? And then over and over again. The beauty here is it's passing that request object around. But the question here is, if I make a change to that request, will that change appear in that second one, right? Because we have established that the three of them are getting called. So how about I actually test that? I never actually tested that before, so let's go ahead and do that. So I'm gonna go here is I'm gonna do request dot, I'm gonna add an object here, so I don't know, value, which doesn't exist, equal 1, right? And then I'm gonna actually print that value here. Request dot value. If I can type, right? And then followed by 2, right? Let's do that. Then and then 3. Let's just print 3 there. So what I expect here is, since I didn't print anything there, I expect that request.value will have the key, will create a new key of value 1, and then that request will be passed, and we're going to use that. So it's either, if we see 1 here, 1 space 2, that means the second call to the request was actually fulfilled successfully, and we got the value. If we see undefined, that means our theory is incorrect. How about we actually test it? And do another run, go here, and we actually were right. So this is very valuable. You know, you can, and this is, I believe this is how Express works when it comes to middleware, right? The idea of middlewares, yeah? Is that how you spell middlewares? Not sure. Like, if you add like a JSON body parser to the middleware, we receive the post request usually, and that has a JSON body. Okay, usually we're too lazy to actually look at the body and parse the JSON, understand what it is. So there's a middleware in Express that actually reads the body, parses the body to a JSON, and then stores it into an actual value called JSON body, whatever, right? You can do something like that if you want. Now, I believe there are a lot of middleware. Once you set that, so the middleware will run first, process the request for you, and then your functions that you add will get called later with a brand new request function effectively, right? So that's actually pretty cool if you think about it. You have a lot of control at this low-level API. So now that we understand the request, how do I actually write something to the poor client? I'm going to write the value of 1, right? The second one here, I'm going to write Response.write 2, right? And the third one, I'm going to Response.write 3. I want you to notice something here. If I do now, let's do this, clear. If I do curl, immediately notice what will happen here, right? The connection was terminated somewhere. Yeah, look at that. This is something I never knew. You cannot send an integer. It has to be either a string or an instance of a buffer or an integer array. That's interesting. So string works, right? So all right, let's send the string 1, string 2, string 3. That makes sense, right? They have to restrict it to certain types. They cannot just go, right, Wild West. So let's go ahead and do that again. Boom. Now you see that what happens here is we sent the request, right? And then we actually got more information, because in curl, by the way, this indicates that you sent data, right? This indicates that you received stuff. So just the fact that we wrote something to the client, we also sent the default headers, which are HTTP 11200 OK, which means this is the protocol, this is the status, and I believe this is the translation of this, if I'm not mistaken. The another header was sent. This is the date, the connection. It says it told the client to keep the connection alive, and then there is a timeout, right? For 5. I don't know what 5 represents, because hey, we've been here for a long time and still didn't disconnect. So that timeout means could be on something else. And the fact that we wrote something, that is an indication to the kind of content that we're sending. It's a transfer encoding. It means chunked, which means, hey, I'm gonna chunk the request to you slowly. So we did send 1, 2, 3, but if you notice, none of those came back to the client. And the reason is because write actually does not send the responses to the client. So let's read what write does here. The writable write method writes some data to the stream, right? So the socket, right? It writes these data, right? And then it calls the supplied callback once the data has been fully handled. If an error occurs, the callback will be called with an error as its first argument. The callback is called asynchronously and before error is emitted. The return value is true if the internal buffer is less than the high water mark configured when the stream created after admitting chunk. If false is returned, further attempts to write the data, the stream should stop until drain event is emitted, right? So if you notice here, there is a there is a variable here. So what is that? Can I change that? So that function says the high watermark configured when the stream was created after admitting chunk. If false was returned, further attempts to write data to the stream should stop until the drain event is emitted. So as you think about these blocking scenarios and when the data actually gets to the user, you really need to, like, it can impact performance if you think about it, right? So how can I let my data get sent, get flushed, if you will, to the client regardless of its size? Right? First of all, let me show you exactly that high watermark, if you will. So what I'm gonna do here is I'm gonna print that thing, the high watermark value, and if I'm not mistaken, it might be this guy, writable high watermark. It might be that value. So let's go ahead and print it, right? So I'm gonna do hard bun, and let's do that. So now if I make a request here, right? Let's go ahead and make a request. Boom, boom, boom. You can see that writable high watermark is 16,000 bytes, which means that if the write buffer reached 16,000 bytes, then it will automatically flush that. Well, sometimes I'm building a game, for example, and I'm sending the inputs. The user, the game user moved forward, backward. I want that input to arrive as fast as possible, right? Or I'm building, for example, a chatting app. If I'm sending a message, I want that message to be arrived immediately, right? So this can be solved by literally just calling end, right? Let's read through this. It's like discovering the lore, if you will, of the Node.js stuff here. So let's start. End. Calling the writable end method signals that no more data will be written to the writable, right? So that the writing that we talked about, the optional chunk and the encoding arguments, right? Is that what it is? It's okay, because end takes kind CB, it takes a function that returns a void, right? Allow one final additional chunk of data to be written immediately before closing the stream. Interesting. So calling the write method after calling end will raise an error, because that is by design, because that's what they said. So now, what is wrong with my code as it stands today? I'm writing and I told end the stream. That means flush whatever you wrote to the client. Yeah? That means prepare the response and prepare the segments, the TCP segments, and then prepare the destination IP and the destination port, and then send it back to the client, right? And if I'm not mistaken, that might also override Nagel's algorithm, which kind of indicates to wait for a full maximum segment size before the data is sent, right? I'm not sure about that, because there must be a configuration to enable and disable that, right? And Nagel algorithm only takes effect if there are unacknowledged data, obviously, right? So let's go ahead and do that. See what will happen. Boom. Look at this beauty thing. We got a response, guys. One. We got it. But look at this. We're getting errors in the debugger. You probably have guessed it. Why? Because I'm writing after the fact that I ended. So that's why 2 and 3 never made it to the client. Only 1 made it. Okay? So now, see, this is the error that they're throwing. Error stream right after end. Right after end. So that's the error. So the logical code really for me is either add it right here, or since I don't like curly braces, I can remove these guys, right? And I can add an end right here. And it says here that you can final chunk. I do not see it. It takes a function, right? That's kind of weird, right? Yeah, so like this looks weird to me, right? Because end kind of takes a function, right? But it says, hey, it sounds like the documentation is weird. Or I didn't understand that. But it says like, hey, you can send a segment, send a final chunk. All right, let's send a test. This is end, right? Well, this is end, make it. The signature doesn't say that. Huh, it did make it. That's awesome. So 1, 2, 3, this is end, right? So the beauty here is you can end the stream, right, that responds and also send data during that thing. So that's fascinating stuff. You think about it, right? And I can't think of a lot of examples where you want to do multiple, events, if you will. But you might have, you might be building a framework like Express, and you want to make these as flexible as possible, right? You know what Express does, right? What Express does says, hey, I want, I don't know, server.get, and you call a method and you specify the path, right? Say, hey, if this path was called, call this function, right? And you do your stuff right here. So how does that exactly work when in that configuration? Well, what I can do here is effectively build an array of gets, right, functions, and an array of posts function. And I'm not going to do the paths for now because it's not really hard to do. But and I'm going to build a function called get right here. This function technically takes a function. And that function is literally just pushes that function right? To this array of functions. I'm going to do the same thing with post and keep this around, if you will. So what I'm going to do here is go server.own when someone sends me a request, right? Obviously, request has to do request and response, right? And what I'm going to do here is I'm going to do an if statement here. If the request, the method is equal get, then I want you to loop through all the gets that have been added and literally call them. So how to do that? Well, we have the array right here, right? Okay. Right, and you can just literally call that function. But that function will really need to pass in whatever the request and response were, right? And you can do the copy and paste, and you can do the exact same thing for what? For posts. This way, this is a bug, posts, right? This way, you can effectively wire events, right? Just like Express. It's a little bit rudimentary compared to Express, but you get the point, right? So now what I can do is something like server.get, and I'm call a function, and immediately do this, right? And I'm gonna do Response.End get 1, right? I'm gonna go to another function, get 2. Let's do received your get 1, and then received your get 2. Let's do a post, 2 posts. Someone do the post, received your post 1, you received their post 2. Sweet. So just like that, we're building functions right here, right? And you can do all sorts of logics, just like we have in Express. The only difference is in Express you have also a path, right? Which you can add the logic right here. You can search for the path and only call the functions that matches the path that the user passes, and you can get the path from the request. So let's test this. Does this actually work, right? If I do this, by default, curl does a get if you don't tell it anything. So now we're getting a failure. Server.get is not a function because I am a genius, right? Because I called it before I actually defined it. What a genius, Hussein. What a genius. Gotta do it here, right? Now let's do it again. Run. Boom. You can see received your get 1, and we made a mistake. Why did we only get received your get 1 and we didn't receive your get 2? Because it's your fault as a developer. You ended the response very prematurely. You can do this in this case, right? You can write and then end, and write and then end. And that, if I obviously run the server again, do a girl, right? Now we get both of them. Can you see them? Receive your get 1, receive your get 2. Hussein, how about post? How about post? Does your post work? Because I don't believe you. Well, let's do a post. curl-x post http localhost this time. Let's not be fancy. This means I can use the post method. In this case, I still want verbose. And now, received your post 1 and received your post 2. You might say, Hussein, why I don't like this? Like, why there are no new lines? Hey, curl and NodeJS respects what you did. You are exactly what you sent will exactly be sent. No new lines will be added because new lines are data. We don't just send additional data, right? Just add additional data from our, armpit. We need to respect what the client tells us. So if you want new lines, do this. Boom, boom, boom. Right? If this is like causing you anxiety, do this. Much better, right? All right, guys. So let's summarize what did we learn here. We learned that, and sorry about my voice because baby's sleeping on the other room, so gotta speak quietly. And what we learned here is Node.js, the HTTP beautiful library, right, that is, will allow us to add an event called request. And when the client like curl or Postman or Python request library sends us a request, an HTTP request, that will be translated into TCP land as a bunch of segments, right? And the segment size default to 1500 bytes, right? So if you have a large request, like you're suddenly uploading a file, that will translate to many segments, right? So this beautiful library will buffer all these TCP segments, right? The operating system will receive the segments, will know which process to send them to because we have the port, right? Port 8080 in this case, right? It will immediately, any segment that we get, the TCP stack in the operating system, in this case Mac, will send an acknowledgement to the server, and if delayed acknowledgement RFC is enabled, it will delay and send it after 40 milliseconds, just to don't overwhelm the bandwidth. And then once we receive enough amount of data, these segments will be sent to the application, which is this. HTTP library is doing a lot of work for us here. And it says, okay, so we're gonna buffer, read, and we'll start reading. So it says, okay, I got your post, I got this, I got this. And up until here, it will never call our function. It will never call this event. Only when the actual new line is received, that is an indication that this is the end of the request, right? And usually there is a content length that will allow us to know where the end of the request is. But if there is none, it will basically assume there is nobody, right? And it will end right there. So that will basically determine the size of the request. And boy, this is huge. How do I know this is the end of the request and this is the beginning of the second request? This is where HTTP smuggling happens, right? Because we're dealing with strings, geez, a lot of hackers actually take advantage of this and sneak in another post request within a post request, and some web servers like this one, for example, will never know where's the end, where's the start, right? So we'll choose a different ending, and based on that, if you have reverse proxies or load balancers, things can go really wrong. But yeah, once we know the boundaries, if you will, of the request, we will take these requests and then pass that request object with not only that, HTTP will do a lot of work for us. It will parse the headers. It will understand that this is a post method, like it will populate a variable in itself called method, right? Because by default, none of this stuff exists. You can argue you can build the HTTP library from scratch using the TCP net library, right? I believe it's called net. Yeah, the net library, by doing exactly what it's doing. And you can build Express using HTTP, right? And it's just, I like to make these videos just so I can just unveil behind the curtain what is happening, from scratch. It's just so much stuff that we take for granted. And once we understand this, we can optimize our code. We can debug our code if things went wrong, right? Because we understand what's happening, right? So once we have a beautiful single request, that request will be called for every instance of an event that has been assigned to this event. So this function will be called with the request object and an empty response object, right? That will be filled with every function. So if you call this, you fill it, and then that filled new state will be passed to the second one. So if these are accumulative, the request and response, and we proved this in the beginning of this video, if you will, right? And that's it. So at the end of the day, you build your response, and then you call end. You write, and when you're done, you call end, right? And once this is end, this is an indication for the HTTP library in this case to say, hey, don't call any more functions. Stop right here. So it will never bother calling other functions. Actually, you know what? I take that back. Actually, it calls other functions, but it fails with that error that we saw, right? Which is, hey, the chunks has been already sent. All right, guys, that was it for me today. Hope you enjoyed this video. I'm gonna see you on the next one. Goodbye.